Hello guys, welcome to PerspiScience. In this video we will focus on projectile motion. First, what is a projectile? A projectile is an object that has been given an initial velocity and moves under the influence of gravity. Have you ever wondered why every time when you draw a stone upward, it will eventually go down after some time? The reason is simple. It's because of a force of gravity that pulls everything on Earth towards the center of the Earth, or pulls every object downward. Example of projectile motion is a kick the soccer ball, or a netball shot, or a packet that falls from a moving plane. So in projectile, there are special terms which are being used, or key points. Let's take you have a building, for example of 70 meters height, and we have a boy who is standing on top of a building, and the boy is holding a ball. So this boy decides to throw the ball upward. What we know is that if this boy will throw the ball upward, the ball will go up, but the time will arrive when the ball will change a direction and will now go downward till it hits the ground. But why does the ball goes downwards after some time? It is simply because of gravity. So when you are dealing with projectile, before doing a lot of things, you have to choose direction. So if you don't want any complication, always choose upward as positive and you choose downward as negative. Since we know that this ball eventually after some time it will go downward caused by gravity, we will say the acceleration of this ball will be negative 9.8 meters per square second. Why negative 9.8? Because of gravity. So, the points that you have to keep in mind when you are dealing with projectile is the first point where the ball is being projected upward. The first point is called the point of launch. This is where the boy initially launched the ball upwards. So, as the ball is being launched upward, it will reach a certain height where it will change the direction and start to move downward. So, this certain height is called a maximum height. Maximum height. And we believe that after some time, as this ball now is going downward, it will pass another point which is equivalent to the point of launch. But the different thing now is that the ball is going downward. So this point, we will call it a point that passes the point of launch. Is a point that passes the point of launch. Then the final point is called the ground. So let's say for example this boy projected or throw this ball upward with a velocity of 4 meters per second. First, we will choose this first velocity to be positive because initially the boy decided to throw the ball upward. So we'll say positive. But what happened at the maximum height? Since we saw the ball, it was going upward. But at the maximum height, it changed the direction and started to move downward. Which means in the maximum height, the velocity will drop to 0 meters per second. Keep it in mind that when they say maximum height, velocity is 0 meters per second. They might not give you the velocity in your exam. So it is always 0 meters per second in the maximum height. What about the point that passes the point of launch? At this point, when the ball was going downward, this point, you have to keep it in mind that the velocity of this point, it will be the same velocity which the ball was projected with initially upward. But what changes? What changes is the direction. So it will be negative 4 meters per second. Since now we say downwards have to be negative. As the ball continues to go downwards, the velocity will increase. We may assume that here at the ground level, the ball will hit maybe with 8 meters per second. So when dealing with projectile for 2 dimension, you have to know the equation of motion which we did in our previous video. The first equation of motion says Vf is equal to Vi minus acceleration multiplied by delta t. The second equation of motion says Vf square equal to V initial square plus 2 acceleration multiplied by change in x. The third equation of motion says change in x equal to V initial multiplied by delta t plus a half of acceleration multiplied by delta t raised to the power 2. So you have to keep these 3 equations of motion in mind when you want to deal with problems under the topic of projectile. Another thing that you must keep in your mind is that always when you're dealing with projectile, choose your acceleration to be negative 9,8. And for the sake of not making mistake, always choose upward as positive and downward as negative. Another thing that you need to know, as this boy was projecting this ball upward, the time was moving. It might happen this ball, for it to move from the hand of a boy to reach the maximum height, it took, for example, we can say it took 9 seconds for the ball to move from the hand to the maximum height. It took 9 seconds, which means also for it to move from the maximum height and reach the point that passes the point of launch, it will take another 9 seconds. Keep it in mind that the time for the ball to move from initial to maximum height is equivalent to the time from maximum height to the point that passes the point of launch. Keywords that you must know. When they say the ball is dropped, dropped means V initial is equal to 0 meters per second. So what you have to know is that whenever you have an object, for example, you have a stone in your hand, you decide to throw it upward, maybe with an initial velocity of 2 meters per second, that same stone will go back in your hand with the same velocity of 2 meters per second, but now it will be having a negative direction because now it will be going downward. So meaning the initial velocity is equivalent to the velocity in which the object will be moving from the maximum height to the point that passes the point of launch. As this ball have projected or have thrown this ball upward, when the ball reaches the maximum height, once it starts to fall downward or goes downward till it reaches the ground, this is called free fall, which means I can say here A, here B, here C, and the ground is D. I can say from B up to D, the ball was in free fall. Keep that in mind. Free fall from maximum height till the ground. Free fall, they will say define it in your exam. Free fall is a motion of an object under which the only force acting on it is a force of gravity. So here the ball was moving downwards, caused only by the force of gravity. So let's look at a quick example. A man climbs up a cliff. His cell phone comes loose from the belt around his waist and begins to fall from rest and land in a pool of water which is 60 meters below him. At what velocity does the cell phone hit the water? So first, we have to collect our data. Things are different here in Projectile. When you are collecting data, you have to check for 5 things in your data. First, you have to check V initial if you are given, and you have to check V final if you are given. You have to check change in time if you are given, and you have to check change in X or change in Y. It will depend on the motion of an object. If the object is going horizontally, we will say change in X. If it is going vertically, we will say change in Y. Then the fifth thing is acceleration. Acceleration, always you are given. Even if it is not mentioned in the statement, you have to know it is a constant, negative 9.8 meters per second. So in the statement, they say that the cell phone became loose from the belt, which means initially the phone was inside the belt. Then we will assume that the initial velocity is 0 meters per second. Since initially the phone was on a belt, then it became loose. And the question says we must find the final velocity in which the phone will hit the water. So you put a question mark on VF. And change in time, in this situation, you are also not given. But change in Y or change in X, we are given on the statement, which is 60 meters. So this data will help you then to choose the best equation of motion which you will use. Meaning that you will look for an equation of motion that include V initial and V final, obvious because it's what you're looking for, and change in X and acceleration. So let's look at the best equation of motion that we can use. The first equation of motion, it have V initial, correct? It have V final, correct? It have acceleration, but it have change in time. And in our data, we don't have change in time. So we can't have two variables because we are also looking for V final, which means the first equation of motion is cancelled. Let's go to the second equation of motion. It have V final, what we are looking for, correct? V initial, correct? Acceleration, correct? Change in X or change in Y, correct? Which means the second equation of motion, it can work better for us. What about the third equation of motion? It have change in X, which is good, V initial, which is good, change in time. We are not given change in time in the statement, so the third equation of motion can't work. We will only use this second equation of motion. So let's go and plug in our values. First, we will write our second equation of motion, which says Vf square is equal to V initial square plus 2a change in Y. Since now the phone just got loose from the belt and the person was on top of a hill, meaning it will go vertically downward. So if it is vertically, it will be change in Y. So the V final is what we are looking for. V initial, we say it is 0 because initially it was on a belt. So 2 into negative 9.8 for acceleration. What about change in Y? We are given as 60 meters. Do we put positive or negative? We put negative because the phone was falling up in a cliff, which means it goes down. And down, we always choose it as negative. So you will press your calculator. On the right hand side, you will get 1176. So we want VF, not VF squared. So we have to introduce square root both sides to remove the square. So VF, which is the final velocity in which the phone will hit the water, will be equal to positive 34.29 meters per second.
Downward. Thank you guys for watching. On the next video, we will continue with more problems in projectile. Kindly like and subscribe on PerspiScience to be notified with more videos.